We want to start our work with solving trigonometric equations. Here's the first one I've written on the board. Let's solve 2 cosine theta minus square root 3 equals 0. We're going to treat the whole expression cosine theta as if it was just a single variable. So I'll start by adding square root 3 to both sides. 2 cosine theta is equal to square root 3. Next, I want to isolate cosine theta on one side, so I'll divide both sides by 2. Cosine theta is equal to square root 3 over 2. Okay, so I'm looking for all values of theta, first of all, between 0 and 360 degrees that make this a true statement. So the fact that cosine theta is square root 3 over 2 tells me that my reference angle in this case is going to be 30 degrees. Then I ask myself, okay, where is cosine positive? Cosine theta is equal to positive square root 3 over 2, so where does that happen? Well, cosine theta is positive in quadrants 1. Okay, so 30 degrees in quadrant 1. And since cosine goes with the variable x, I know that cosine is positive in quadrants 1 and quadrant 4. So I'm going to draw in a reference angle of 30 degrees in quadrant 4 and name this angle as 360 degrees minus 30 degrees, which will be 330 degrees. Okay, so right away, if cosine theta is equal to square root 3 over 2, that tells me that the reference angle is 30 degrees. Then I know that there's two possible angles between 0 and 360 that have this for a reference angle and are also positive. So, and where the cosine of them is positive, and that's going to be in quadrants 1 and 3. So that tells me that theta is equal to 30 degrees and theta is equal to 330 degrees. Now, suppose I want to write all solutions. Well, I only have two between 0 and 360, and then I can add on any multiples of 360 to those, and I'll end up with an angle coterminal to them. We'll have the same cosine. So when I want all solutions, I write down theta is equal to 30 degrees plus 360 degrees times k, where k is just an integer, 0 plus or minus 1 plus or minus 2, so on and so forth. And then the second solution is theta is equal to 330 degrees plus 360 degrees times k. So here's my solutions between 0 and 360. Here's all my solutions to that equation. Find the reference angle, check the sign, the algebraic sign plus or minus of the trig function. That tells you in which two quadrants you go. Write your reference angle in those two quadrants and then name the angle that, that has those for a reference angle. Let's try another problem. Okay, here we have an equation, 4 sine t minus square root 3 equals 2 sine t, and I want to find all radian solutions to that equation, and just the radian solutions between 0 and 2 pi, including 0 but not including 2 pi. Let's see. So I'm going to start by adding negative 2 sine t to both sides, so I'll get 2 sine t minus square root 3 equals 0. Now I'll add square root 3 to both sides. 2 sine t is equal to square root 3. Then I'll divide both sides by 2, and I'll get sine t is equal to square root 3 over 2. Okay, well I see sine t is equal to square root 3 over 2. That tells me that t must be equal to, or the reference angle for t must be equal to 60 degrees, or, well, let's do that, 60 degrees or pi over 3 in radians. I generally tend to think in terms of degrees, and so I might write the degrees down first, and I know my answer should be in terms of radians, so I'll write down the pi over 3. Okay, so if that's the reference angle, and it's a sine that's positive, so the sine function is positive in quadrants 1 and 2, then I can write my reference angle down like this. Okay, reference angle of 60 degrees looks like this. 60 degrees equals pi over 3, so that's 1. And then also I want the reference angle in quadrant 3 because it's a sine function and sine's positive in quadrants 1 and 3. So I'll put my reference angle over here again. This is 60 degrees equal pi over 3. Okay, and then I want to name this angle right here. And I want to do it in radians, so that looks like, let's see, that'll be pi minus pi over 3. So pi minus pi over 3. Well, that's 3 pi over 3 minus pi over 3, so it should be 2 pi over 3. And that makes sense. So if sine t is square root 3 over 2, a positive number, then the reference angle is 60 degrees, which is pi over 3, must be in quadrants 1 or quadrant 2, in which case I'm going to get angles of pi over 3 or 2 pi over 3. So I'll fill this in first. T is equal to pi over 3 or 2 pi over 3. So those are my two angles in between 0 and 2 pi written in radians. And then all radian solutions, I'm going to add on multiples of 2 pi to this, because any time I add on 2 pi, I get an angle coterminal with my original angle. I had a little malfunction with the camera there, so let's finish this problem here. We had all solutions between 0 and 2 pi was pi over 2 and 2 pi over 3. When we want to write all solutions, what we do is we add on multiples of 2 pi. Since our original solutions here between 0 and 2 pi are in radians, we'll add on radian multiples right here. So 2 pi times k, 2 pi times k, that's what we add on. K is any integer, 0, plus or minus 1, plus or minus 2. Then we get all the possible angles that are coterminal with these two. There's an infinite number of them, each of which is a solution to the original equation. Here we go with the next problem. Okay, here I have another trig equation. 2 cosine theta minus 5 is 3 cosine theta minus 2. Let's solve this equation. Let's see, I have 2 cosine theta here, 3 here. If I add negative 2 cosine theta to both sides, I'll have negative 5 is equal to cosine theta minus 2. And now I can just add 2 to both sides and get negative 3 is equal to cosine theta. So negative 3 is equal to cosine theta. What does that mean? Well, let's take a look here. I can draw my graph in. Let's put in 360 degrees and 180 degrees. Here's negative 1, positive 1. And let me graph just a quick little sketch of one period of cosine theta. It's going to look like this. Okay, so where is this going to intersect the graph of y equal negative 3? Well, y equal negative 3 is going to be down here. That go off the board? No. It will never intersect that graph. So there's no solution to this equation. Cosine theta has to be between negative 1 and 1. It can never be negative 3. No matter what you do, if you put a negative 3 on your calculator and look up the angle whose cosine is that, you're going to get an error. So in this case, the solution set is the empty set.